Good morning. My name is Sumit Prihar and I am a student of CSE A Division. Today I am going to present my ISE activity 1 of IoT, that is video presentation. My topic is sensor interfacing and IoT. Sensors are eyes and ears of IoT, transforming physical data into digital insights. Sensor interfacing is an important part of connecting physical data to microcontrollers. It involves transformation of physical analog signals into digital signals that are understood by computers. This framework of sensor interfacing is mainly divided into four steps. First one is physical world. It says that the physical data like temperature and pressure exist. Second step is data acquisition. In this step, sensor acquire physical data like temperature. Third step is signal conversion. In this process, physical analog signals is converted into digital signal. Fourth step is digital interpretation. In this step, microcontroller microcontroller interprets and analyzes the converted digital signal. Sensor interfacing is an important step for analyzing this physical data. Next point is key components of sensor interfacing. So, sensor interfacing mainly consists of three key components, out of which the sensors and actuators are at lowest level. Sensors are basically the devices which detects physical changes, and actuators are devices which generates physical responses based on these changes. Second component is signal conditioning circuits. This basically refine the raw signal from coming from sensors, which includes amplifying or filtering these signals and removing unwanted noise from these signals and making them optimized for further processing. Third component is microcontrollers and data acquisition units. These are also called as brain of IoT, which converts the conditioned or uh, refined signals into digital data and process it for further communication. We can see the hierarchy of these components in the figure also. Next step is type of sensors. So basically IoT nowadays provides a vast variety of sensors to us. These sensors can be mainly divided into four categories. So first one is environmental sensors. These measures data about environmental aspects like temperature, humidity, pressure, air quality, etc. Second category is presence and motion sensors. It mainly detects motion of any object and includes technology like infrared. Third category is light and gas sensors. It uh, detects and monitors ambient light and other component in the atmosphere like carbon, carbon monoxide, etc. Fourth one is biometric sensors. It monitors data or biometric data like fingerprints, heart rate, facial recognition, etc. Next point is type of sensing done by sensors. So sensors are used at a large scale nowadays, but these sensors provide mainly three types of sensing. First one is environmental sensing, in which sensors monitor ambient data like temperature, humidity, and light levels in smart buildings, agriculture, greenhouse, and etc. Second one is continuous monitoring done by sensors. It provides continuous data streams for crucial applications such as vital signs of a patient in healthcare and uh, machinery performance in industry. Third type of sensing is real-time data feedback. In this type, it provides instant data to IoT platforms for enabling immediate response and automated actions. Example of this real-time data feedback is traffic signal control. So next point is IoT stack from sensor to application. So the IoT or Internet of Things basically operates on a layered framework which starts from physical layer to the complex layer such as application user interface. So lowest level of IoT stack is physical layers which is also consists of sensor and gathered data. Second layer is network layer, which in this layer the data collected by physical layer is transmitted. Third layer is the processing layer, which analyze this transmitted data and triggers a specific action. Last layer is application layer, which provides user interface and services. So in this pyramid, we can say that physical layer is at bottom, next is network layer, and third processing layer, and last is application layer at topmost. So next point is enabling technologies for IoT. So uh, the IoT is now is ongoing with a robust growth, and it also has the support of many edge-cutting technologies coming nowadays. Few of them are sensor technologies and embedded system. In this technology, minute size or low power sensors are integrated with embedded processing unit for localized intelligence, and it does not require a central control. Next is connectivity. So this technology consists of wireless protocols like Wi-Fi, Bluetooth, etc., and it ensures the wireless communication between devices and the cloud. Third one is cloud computing and big data analytics. So sometimes the data collected by sensors is so huge that it cannot be stored at one unit, and processing of such amount of data is a difficult task. In this case, cloud computing and big data analytics come into role, and it provides a large amount of space for storing this data, and it also provides new techniques for analyzing uh, these big data. So our next point is wireless sensor networks, that is also known as WSN. Wireless sensor networks are a subset of IoT, which can be also be called as a network of spatially distributed sensor nodes. It collects It also monitors physical data and environmental condition. A spatially distributed sensor node consists of a sensor and microcontroller and a radio transceiver which transmits the data. It it forms a self-organized network. So some applications of wireless sensor networks are as follows. First one is military surveillance. WSN provides a real-time surveillance for military operation. Next application is smart cities. It enhances living condition in urban cities or smart cities through IoT applications. Third one is environmental monitoring. It provides and track real-time environmental changes and conditions remotely. Last one is healthcare industry, and WSN also monitors patients' health through uh, vi- uh, patient health and vital signs wirelessly. Next point is WSN versus IoT. So although it seems that wireless sensor networks and IoT are doing the same things, there are still some difference between these two. We will see these differences next. So, focus of wireless sensor networks is basically on collecting the data and reliable transmission of this data, whereas focus of IoT is basically on uh, integration of broader category of devices, cloud services, and applications. Next point is scope. So scope of a wireless sensor network is closed, and it performs a specific monitoring tasks, whereas scope of IoT is very large or open scope, and it provides diverse services and automation. Third point is interoperability. So it WSN has limited operability, and IoT has a high interoperability. Next point is relationship. So we can say that wireless sensor network is a subset or a fundamental component of a IoT system. Example of wireless sensor network can be temperature sensors in a greenhouse, and example of IoT can be smart home system, which includes controlling fans, light, etc. So here are some application and future scope of IoT. First application is smart homes, which includes automated lighting, security controls, and energy management. Second one is healthcare. In this, remote monitoring of patients and wearable healthcare devices like smartwatches came into role. Third one is industrial automation. It provides continuous monitoring of machines and asset tracking. Next one is smart cities. In, it involves automated traffic management and street automated street lights control and waste management. So from this we can conclude that future has a huge scope for IoT, and we will see a we will see a robust growth in IoT in future. And here ends my presentation. Thank you for watching.